I just feel like America wouldn't let that happen so
I know
easily.
that.
Yeah.
But you know,
It's too important to them that people trade in dollars for gas and oil.
you know the dollar into, if you change, it's like accurate to.
Be quick.
Yeah. It's not in dollar to real. It's never changed.
Yeah.
It's always.
No, I understand. Yeah. It's fixed.
Yeah.
Yeah.
But
It's the same with Chinese currency.
I don't know that. But if they trail oil and drop real, it will be, then it will change.
Yeah. The Chinese currency is fixed against the dollar as well. I don't know what it is. Amanda, how much will $1 American get in Chinese currency, yuan? It's fixed, isn't it?
One Chinese money.
Yeah. 1.6
dollars.
Yeah, so you would need $1 will buy you about 5 yuan.
No, 6.33.
6.33. Okay. See, I think that's fixed as well. It's always 6.33, isn't it? Yeah, it's fixed.
Because you know
in
since
the long ago is maybe.
Oh, it was different a while ago. Yes,
8 or 7.
that's right.
But now
It decreased. They changed it. Yeah.
like since the ICE started to sell petrol, oil.
Have they?
Yeah.
Mm.
That's why the price of oil is decreasing.
I'm sure there's more reasons than just that.
I know it's a main factor too.
Is it?
Yeah.
I'm going to look this up now. I'll look it up. I've not heard that.
Because when since like almost like 30% prices are decreased.
Oh, I know. It's good for me. I pay less now. It was much cheaper than 2 years ago.
The price is not changing in Saudi Arabia locally.
Oh, I know. It's usually constant.
Yeah.
Okay, the next section I want to do, and it's very easy, and it should be very easy for you because we actually did it in physics. So we're going to look at a little bit of trigonometry. So before we start with sine, cos, and tan, a circle. Sorry, KJ, this isn't the hard part yet. So a circle. Now, what unit do we use to measure the angle?
Angle, degree.
We usually use degree. Yeah. But instead, we can use this here, arc length, to measure the angle. Okay? So for example, if I have one full circle, let me actually write this down. I'll do it in red. We could use, if I call this L, theta is L over R. So one way we could measure the angle if we don't want to use degrees is we could use this number divided by this number. So let me just draw that again. So for example, let's say the radius was 2 meters and here to here, I don't know, let's say this was, 3 meters. Then the angle would be 3 divided by 2, which would be 1.5. And we're calling this new way to measure the angle, we're calling it a radian. So this is the new way to measure angles. We can use radians. And a radian is the arc length divided by the radius.
We used it really.
Hmm?
We used it.
I know. Oh, I know. I remember what I teach you. Don't worry. So, how big is 1 radian? Well, let's have a look.
57.3.
No, that wasn't really a question, but thank you for answering. So, suppose I have one full circle. This is R. Does anybody know how big this is for one full circle? Anybody remember from middle school? 2 pi r. No, 2 pi r. So one full angle, a full circle, would equal 2 pi r divided by
Circumstance.
R. Circumference.
Circumference is equal to 2 pi r.
So a full circle is equal to 2 pi. So this means 360 degrees is equal to 2 pi radians. So then 1 radian is equal to 360 divided by 2 pi, which equals 180 divided by pi, which equals roughly 57, I thought it was. 57.3 degrees.
Why do you divide by
Can I scroll down?
why did you divide by r?
That's the definition from just the line previous. The arc length divided by the radius is the angle.
The circumference always 2 pi r.
Yes. So the angle is the, yeah? Okay. So, look, what that means is, if you have 1 radiant, the radius and the arc length are the same. Guys?
It's smaller than.
Yeah.
Okay.
This is the key about using radians. In radians, if the angle equals 1, then it means you have this here is the radius. The arc length is also equal to the radius. So these three are the same when the angle is 1 radian, when it's 57.3 degrees. This is what makes radians useful. So you know every time you have 1 radian, how big is the arc length? It's the radius. So for example, if I had an angle which was equal to 2 radians,
It will be half r. No, sorry. Double actually.
2 r.
Like a diamond.
Do you see what's happening? That every time I have 1 radian, I have r as the arc length. So if I had 2 radians, then I have 2 r's. Does that make sense? Yeah. So this is why radians are important. This is what makes them important. Okay, can I scroll down now?
1 radian equal 1 r.
1 radian means the arc length is 1 radius. Yeah.
So L or R equal to the.
Well, basically L equals R, that the arc length would be equal to the radius.
Okay,
If
but
radius is
the
one.
theta is 2.
Then it'll be 2R.
2 r.
Yeah, L would equal 2R. Yeah, yeah. So like, if the theta equals 1, then the arc length equals R. If theta equals 2, then the arc length equals 2R. If theta equals 3, then you have 3R as the arc length. So look, since we're all doing physics, let me just show you something really quick here with the circle. So think about this. Remember I said the omega is radians per second. So if the omega equals 2 radians per second, then that means in 1 second, this has moved, what's the angle here? 2. yeah, in 1 second, the angle here is 2. Because that's what I said in my example. Okay? Now, let's say the radius here is 10 meters. How big is this? 20 meters. Very good. So, in 1 second, how far has it traveled? It moved 20 meters in 1 second. Therefore, V equals 20 meters per second. Now, remember I gave you this formula, omega equals V over R. Yes? So what does V equal? Omega R. What's omega? 2. And what's R? 10. So what is it? The same, see? So this is why radians are important. Because if you use radians, then this formula works. And the reason it works is because you can easily calculate the distance it travels. If you want to write this down, you can, but it's really more physics than maths, okay? But this is what I remember I was saying in physics class, you must use radians. And this is the reason why you must use radians, for these formulas to work. Yeah? Okay. So, also you should remember from physics, how do you convert? So does anybody remember here, if you want to go from degrees to radians?
Okay, cross multiply.
Well, what did I say? I think I said this in class, or maybe not. If you want to go to degrees to radians, you multiply by pi over 180, if you want to convert. And if you want to go from radians to degrees, you multiply by 180 over pi. So please note this. It's important. Yep. Okay, so take out your calculators and very quickly tell me what 20 degrees is in radians. And then tell me what 3 radians are in degrees.
20 is
So
0.3.
So 20 degrees is 0.349
349.
radians, and 3 radians are equal to what?
171.88.
171.887
887.
degrees. So what you do is you multiply this by pi over 180 to get the answer, and here you multiply this by 180 over pi to get this answer. So this is how you convert.
They are opposite.
Yeah. Yeah. Okay. Continue? Yeah. Right, so some vocabulary which you know from physics. Let me call this angle theta. Let's see. Amanda, do you remember the name of this side? No, don't look. Do you remember? Sohi? No. Tekken? No. Okay, try and say it. What's it called? Hypotenuse. Very good. Very good, Tekken. Now, Karar, do you know the name of this side? Yeah. And then Grace.
I just know.
Okay. We'll get to you, Yemi. Adjacent, yeah. Adjacent. So we've seen in physics already, if you have an angle, the sine of the angle we say is the opposite over the hypotenuse. And the cosine of the angle we say is the adjacent over the hypotenuse, and the tan of the angle is the opposite over the adjacent. So for example, if I had a triangle like this, I would say sine theta is equal to 0.6. What would cos theta equal? 0.8. And what would tan theta equal? 0. Well,
0.75.
0.75.
Yes. 0.75.
The reason these are useful is because your calculator has these values built into it. So for example, can I scroll down?
Yes.
Yeah. Can I scroll down? Yeah. So the reason these are important is because your calculator can tell you the theta. It has a special function which lets you get the theta. You can type in theta is sine inverse 0.6. So KJ, in degree mode, can you tell me this? And then Grace, can you type this in on the calculator? And then Tekken, type in tan inverse 0.75. So, who did I ask first?
36.8.
So you got 36.8. Amanda, Grace? Yeah, and then Tekken?
36.
Yeah. So it doesn't matter which one you use, you got the same angle. So your calculator can calculate angles for you by using sine, cos, or tan. Now, let's have a look at like an example. So for example here. So let's say, for example, you know that this angle is 34 degrees, this is x, and this is 289. And you want to know what the x is. So have a look up here. Karar, what is the name of this side?
Opposite.
Opposite. And then Grace, what is the name of this side? No? Hi, yeah, yeah. What is it? Continue. Got it. Hypotenuse. Yeah. So, Fahad, if I have the opposite and the hypotenuse, should I use sine, cos, or tan? You should use sine because you have the opposite and the hypotenuse. So sine 34 equals x over 289. Soki, can you calculate sine 34 please on your calculator? Sine 34, what is it? It'll be something like 0.59. Okay, thank you. Right, so finally we can have the x. X is 289 times 0.559, and what do you get?
161.606.
161 roughly.
No, it's 6 actually.
166?
161.6.
Oh, so then it'd be 162. Okay, can I do another example?
162.
Okay, scroll down. So So let's say this is 5. I know it's not to scale. 5, 12, 13 theta here. Actually, let's put the theta up here. Whoa, mind blown. Right. In this question here, I want the theta. So, Amanda, what is the name of this side? Adjacent, very good. And Grace, I know you know this one. What is the name of this side? Opposite. And this one here, KJ? This one? Hypotenuse. So
why did you change?
yeah, why? Because the angle is up the top now. So this is opposite the theta. Opposite. Yeah, yeah. Now, we can use sine, cos, or tan. So for example, Taken, if I use cos, what is cos theta, for example? In this one here, what would it be? Yeah.
Sine over tan.
Yeah, but what numbers would it be here? Which number? 5, 12, or 13 here?
12.
Nope, not 12. Do you know, Grace? What number here? Huh? Say again?
5 over
5
13.
over 13. Yeah? Because look, remember, cos is A over H. Cos, yeah, yes. So, if I want the theta is cos inverse 5 over 13. So, Karar, no, you have a, where's your calculator? If you come to class without a calculator tomorrow for your test, I'll throw you out, okay? So, Amanda, can you give me the angle here, please? What do we get? 67.38, yeah? Okay.
And we can use sine here.
Oh yes, of course, yeah. In this case, Karar, you could use sine, cos, or tan because I gave you all three.
Tan I can.
Yeah, tell me, Karar, what would tan be here?
Yeah, tan O over A.
Which in this case?
Opposite.
Yeah, which numbers?
Sorry, 12
Yeah.
over 5.
Yeah. Yes. Okay. The last thing, I didn't actually say it because we've done it in physics already, but just to say it, just to say, if you have x, y, z, Pythagoras, x squared plus y squared equals z squared. But everybody knows this. You learned this in middle school. And you remember doing it in physics, yeah? So for example, let's say here x is 6 and z is 10 and I don't know y. So here I'd have 6 squared plus, yeah, no, let's pretend, okay? Play with me, okay? 6 squared plus y squared equals 10 squared, yes. 36 plus y squared equals 100. Y squared equals 64. Y equals 8. Pretend, okay? Yeah. This is the beginning of the chapter, so it's just basic stuff. But we've already done bits of this in physics, and you would remember it from middle school, so it's not very difficult.
New chapter?
Yeah, trigonometry. So let me give you the questions to do, and you can try them for a few minutes, okay? Yep. Now, these questions are very simple, so I will give you 3 from each, because they're so simple. I want you to do the last 3 in everything. So, NOP, NOP, KLM, GHI, GHI. The last 3. Got it? Okay, so you can start them and do them for 5 minutes and then we'll finish, okay? Try, you may even finish them now.